Artificial general intelligence, or AGI, has long been the holy grail of computer science. Unlike today's narrow AI systems, which are trained for specific tasks, AGI would be capable of understanding, learning, and performing any intellectual task that a human can. But is artificial general intelligence actually possible, or is it just a futuristic fantasy? To answer that, we first have to define what AGI really means. AGI goes beyond image recognition, language translation, or even large language models like GPT-4. It implies a flexible, adaptable intelligence, one that can transfer knowledge across domains, reason abstractly, solve novel problems, and perhaps even reflect on its own thinking. In short, AGI wouldn't just follow rules. It would understand them, break them when necessary, and create new ones. Right now, no system can do that. Today's AI models are incredibly powerful, but they're still specialized. GPT-4 can generate impressive text, but it doesn't understand the world. AlphaGo can beat world champions at Go, but it can't tie its shoes or write a grocery list. These models lack what we call generalization, the ability to apply intelligence broadly and adaptively. So why do some experts believe AGI is possible? One reason is scale. As models get larger and are trained on more data, their capabilities improve in surprising ways. GPT-3, GPT-4, and Google's Gemini have shown emergent behaviors, abilities that weren't directly programmed or expected. Some researchers argue that with enough scale, architecture, and alignment, something approximating AGI could emerge. Another reason is biological inspiration. Human intelligence is built from simple components, neurons. Our brains are not magic, they're complex biological systems. If intelligence can emerge from biology, some argue it can also emerge from computation. Neuroscience and AI are converging, and brain-like architectures may help bridge the gap between narrow AI and AGI. Still, there are major challenges. The first is understanding. Current AI systems don't understand the way humans do. They recognize patterns, predict outcomes, and generate outputs. But they don't grasp meaning, context, or consequence the way people can. True AGI would need a richer model of the world, grounded in experience, causality, and embodiment. Then there's reasoning. Human reasoning isn't just statistical. It involves logic, abstraction, and symbolic thinking. Some researchers believe that combining neural networks with symbolic systems, so-called neurosymbolic AI, might be a key to AGI. Memory and continuity are another hurdle. Humans learn over time. We remember past conversations, grow from mistakes, and carry context across months and years. Most AI systems today operate in a session-by-session basis. They don't have long-term memory. AGI would likely need persistent memory and the ability to build on knowledge across time. Motivation and goals present another complexity. What drives AGI to act? What values or objectives would it follow? Human behavior is shaped by emotion, social context, and long histories of evolution. Programming these into a machine is a monumental task and raises profound ethical questions. Let's also not ignore alignment. Even if AGI is possible, aligning it with human goals, values, and ethics may be harder. The more capable a system is, the greater the risk if it acts in unintended ways. Researchers worry about reward hacking, misaligned objectives, or AGI systems, developing instrumental goals that conflict with human well-being. So where are we today? We're somewhere between narrow AI and early hints of generalization. Large language models, reinforcement learning agents, and multimodal systems are expanding the boundaries of what machines can do. But AGI remains elusive. There is no consensus timeline. Some experts think it's decades away. Others believe it may never happen. And a few argue it could arrive within years. OpenAI, DeepMind, Anthropic and other labs are actively working toward AGI. Their approaches differ. Some focus on scaling, others on alignment, others on interpretability. But all agree, AGI is not just a technical problem. It's also a philosophical, ethical, and societal one. What would it mean to live alongside a non-human mind? How would it change education, labor, governance, and identity? Would AGI be a tool, a partner, or a rival? These aren't just science fiction questions anymore. As these systems become more capable and more integrated into our lives, we inch closer to the threshold. And with that proximity comes responsibility. Even if AGI isn't achieved in the next 10 or 20 years, the journey toward it is shaping our present. The technologies, norms, and policies we develop today will define the landscape in which AGI could emerge. So is artificial general intelligence possible? The honest answer is, we don't know. But we're getting closer to the edge of knowing. And as we approach that edge, we must ask not just, can we build AGI, but should we? And if we do, how do we ensure that it serves, uplifts, and protects the world it enters? Because the future of intelligence, human or artificial, isn't just about capability. It's about purpose. And that question is ours to answer. Some researchers believe that achieving AGI might not require fully replicating human cognition. Instead, we could create systems that surpass human flexibility through entirely different architectures. These systems may not think like us, but they may still outperform us in nearly every cognitive domain. This leads to another important idea: intelligence diversity. There may be many forms of general intelligence, not just the human kind. AGI might think in ways that are alien, counterintuitive, or deeply creative. It might find solutions to problems we never imagined, but it also might behave in ways we can't anticipate or control. That's why interpretability is becoming a core research area. If we can't understand how AGI makes decisions, we risk deploying systems that we don't fully comprehend. Projects like mechanistic interpretability aim to open the black box of AI, tracing how individual neurons and layers contribute to decisions, much like mapping a brain's thought process. There are also geopolitical implications. AGI is not just a scientific or commercial milestone, it's a strategic asset. Nations see AGI as a path to technological leadership, economic dominance, and even military advantage. This has sparked a global race, with countries like the US, China, and members of the EU investing heavily in AGI-related research and infrastructure. This raises the stakes dramatically. If AGI emerges under the control of a single entity, corporate or governmental, it could lead to centralized power unlike anything in human history. That's why some advocate for international cooperation, open research, and public oversight of AGI development. Still, open sourcing AGI carries risks. Releasing powerful models to the public could democratize access or unleash misuse. It's a delicate balance between transparency and control, progress and precaution. Another important consideration is the energy and resource cost of AGI. Training large models already requires massive computational infrastructure, sometimes consuming millions of dollars worth of energy and hardware. As AGI development scales, so do concerns about environmental impact, carbon emissions, and the global digital divide. Can we build AGI sustainably? These are questions being asked not only in labs, but also in boardrooms, universities, and parliaments. And perhaps the most profound question is existential. What happens to us, humans, if we create something smarter than ourselves? Some envision AGI as an empowering force, solving climate change, curing disease, and lifting billions out of poverty. Others fear it could render human labor obsolete, reshape power dynamics, or even act against our interests. To navigate this future, we must cultivate both humility and foresight. Humility to recognize what we don't yet understand, and foresight to imagine what responsible AGI could look like. That means interdisciplinary collaboration, inclusive dialogue, and global cooperation on a scale we've rarely achieved. In the end, the question, is AGI possible? May be less important than, are we ready? Because AGI, if it arrives, won't just be a technical achievement. It will be a mirror, reflecting our values, our intentions, and our capacity to build something far greater than ourselves, and to guide it wisely. We stand today at a crossroads. The path toward AGI is no longer hypothetical. It's a trajectory already in motion. We may be years away or decades, but the foundations are being laid, the systems are being built, and the questions are being asked. Is artificial general intelligence possible? The science says yes, eventually. The debate lies in when, how, and at what cost. What matters most is not just the destination, but the journey. How we build, who we involve, and why we pursue it. Because AGI isn't just about artificial minds, it's about who we become in creating them.